Because what you don't know about energy can kill you. Here's Alex Epstein.
Welcome to Power Hour. I'm Alex Epstein. For those of you new to the show, I am the founder and president of the Center for Industrial Progress. And on this week's show, we are going to discuss the article that you can see here on your screen, Global Warming's Terrifying New Math by Bill McKibben. This article has been all over the web. It's been a sensation. If you look at it, if you can see, it's got 86,000 likes, which is a lot for this kind of a, fairly academic type article. 9,000 tweets, 3,000 comments, many positive. And it's just been extravagantly praised all over the web. Now, my colleague, Dr. Eric Dennis, and Eric is a physicist who's also an expert in mathematical modeling and has studied these issues extensively. We both judged this article as incredibly pseudoscientific and not worthy of scientific attention. And more broadly, we've judged that most of the claims of catastrophic global warming have serious scientific deficiencies and methodological deficiencies. But of course, we see all the time that this is stated as revealed science. And part of what made McKibben's claims so compelling is that he said it's really simple and no one can argue with it. So if we see here, he says 3 simple numbers that add up to global catastrophe and that make clear who the real enemy is. And we'll go into those numbers in a minute. But part of what made us disturbed by this article, but also interested in talking about it at some length, was not only the positive reaction to it, which was really incredibly positive, and basically saying, look, it's been completely proven that global warming is catastrophic. No one can deny it. It's obvious that fossil fuel companies are evil. We need to create a movement to tell everyone they're evil. This is incontrovertible. Science proves it. We've seen that. But what was noteworthy also was there wasn't much reaction against it. Given how wrong this article is in our belief, it was surprising that there wasn't a lot of clear opposition to it. What we found was a lot of people emailed us and asked, what do you think of this? I don't know what to think of it. And then other people gave a response to it, but their basic response was to say, no, this issue is really simple. It's just the other way around. And then they would give their own theory of climate change. And we think both of these approaches are problematic. All 3 approaches are problematic. Celebrating it, not knowing what to think about it because it's science and how can we know what, how can we judge these scientific issues, or having a kind of simple scientific alternative ourselves. And so what we decided to do is we want to address this article, but what we really want to address is what we think is the problem at the root of this and of really 99% of the culture's confusion about the global warming issue. And that is that we are never really taught how to evaluate scientific claims. So that's what we're going to focus on today. And I'm going to click over here and you're going to see that we've got a fairly sophisticated outline here. And the reason for this is I really want to go step by step so that you can see systematically how to think about these issues and where Bill McKibben is wrong and how you, even if you're not a scientist, can know that he's wrong, can know there's something deeply corrupt about the way that he and other so-called scientific people are approaching the issue of climate. So let's start out by just recapitulating his argument pretty quickly. So it's basically that the proof of global warming catastrophe is simple. Scientists have determined 3 simple numbers that tell us where we are in the cycle of climate and disaster and what we need to do. So the first number is 2 degrees Celsius. That's the amount of warming that our planet can allegedly tolerate, and we can allegedly tolerate before it's a complete catastrophe. The second number is 565 gigatons, which is the amount of CO2 that would allegedly cause this borderline catastrophe. And then the third number is 2,795 gigatons, which is the amount of CO2 emissions that are expected to occur in the coming decades. And he says, if you do the math, look, it's 2 degrees. That's simple. 565 gigatons is all we can afford. 2795, that's about 5 times as much as 565. That means we're headed for a mega catastrophe. And he concludes we need to ban at least 80% of fossil fuels, and we can only do that successfully by identifying fossil fuel companies as evil and starting a movement to make everyone believe that they're evil. And he says many, many negative things about the producers of fossil fuels, who incidentally produce 85% of the energy that powers the world. He cites a prediction which he apparently agrees with, that the temperature on our current path will rise almost 11 degrees Fahrenheit, which would create a planet straight out of science fiction. So science tells us all this. We're on our way, almost guaranteed, to create a planet out of science fiction unless we drastically reduce course. All right, so after this, citing this prediction, he does this math. We have to keep 80% of the reserves of fossil fuels locked away, which means basically we have to ban 80% of fossil fuel production and consumption. And then the key to this is building a movement, identifying fossil fuel companies as public enemy number 1. And again, it's all simple science. So I want to ask you, what do you think of this reasoning? And what do you think of this article in particular? And what do you think of the claims of catastrophic global warming in general? Or do you think you're qualified to have any kind of opinion? Do we just need to go by what we're told science says? Or is there something that we can do to critically think about it and even identify very big falsehoods in things that, quote, science says? So if you haven't read the article, I'd recommend that you pause right now and read it. And I want you to notice his repeated appeals to scientists, how certain they are. He either says they're certain or they're near certain. It's almost impossible. They could be wrong. And then also he has this thing he likes to do if he cites large amounts of either facts or apparent facts as incontrovertibly proving his case. And if you go to Bill McKibben's Twitter feed, it's just an incredible overwhelming stream of quote unquote facts that purport to prove that we're heading toward catastrophe. So you can check this out right now. Here's a link to the article, bit.ly McKibben Math. So go read that if you already haven't. Think about how you judge the claims. All right. So our take is you can judge the claims. Now, you can't know everything about science, but there's certain questions you can ask that will enable you to really ferret out a lot of people trying to put stuff over you. And that gets to our next point, which is that there's no option to whether we, who are not scientists, now Eric, who's going to join us in a minute, is a scientist. I mean, he's a physics PhD. I'm not a trained scientist. But so those of us who aren't, and even those of us who are, because most people in science are specialists in one thing. They're not universal experts. This isn't the days of ancient Greece when, one scientist could know all of science that was known at the time. And anyway, the reason why we all need to be able to think critically about science is that history teaches us that scientific certainty or near certainty is one of the most common justifications for unscientific or pseudoscientific government coercion. So and we'll get into this. So we've discussed this actually in a previous episode on the Merchants of Despair episode. So go listen to that if you want some more details. But just to give you an indication now, there was this whole belief that was viewed as completely scientific for a very long time. Really, it still exists today among a lot of environmentalists, but was viewed as just obvious maybe 4 decades ago, and even throughout the centuries of overpopulation, that the human population is inevitably going to be overpopulated, and therefore the incontrovertible conclusion was we need coercive population control measures. So we need to sterilize people. We need to have things like the one-child policy. Many American environmentalists praised China for that kind of thing, and that turned out to be completely bogus. Many people just common sense thought, no, this can't be right for the government to just prevent me from having children. I'm responsible for my kids. I'll take responsibility, but to tell me I can't fulfill my dream of having children, that has to be wrong. And their common sense was actually correct. We have a much better fed world now with 7 billion people than we did in the late 1960s with 3.8 billion people. And so the quote science that everyone was fed at the time was completely wrong. Another historical example is what they called the degradation of the gene pool. This was the justification for a lot of measures to try to genetically control the population, which meant things like forced sterilization, not allowing certain people to have children on the grounds that there was this catastrophe of the gene pool degrading, and that this was somehow proven by the theory of evolution, and there was a wide consensus. And I've read a lot about this in the bioethics literature. And if you look at the old bioethics literature, early 1900s, it's just all over the place. Eugenics, this is scientific. The gene pool, it's a disaster. So there's always this pattern of there's this disaster, we're predicting it, we're certain of it, and therefore, and you have to accede to science. Who are you to tell science that it's not right? You need to comply. And if you think it's going to be really destructive, well, we judge better. We're science, or if we're journalists, we are the messengers of science. And then finally, a more mundane thing that you are probably familiar with if you're, let's say, above the age of 25, is the whole food pyramid propaganda, which basically argued to everyone that eating lots of starch, and some people interpret it as sugar, is the key to human health, and that any kind of fat is bad. And I actually remember following this when I was young and interested in nutrition, and a lot of people did, and they gained a lot of weight because by all indications, this theory is completely wrong. And yet it was promoted as science, as nutrition, as something that should be taught to every school child because it's science, and who can argue with science? So one implication of all of this, when we're thinking about global warming, catastrophic global warming, I should say, is we need to be open to the possibility that this falls into the same category. And thus that when Bill McKibben and others claim that we need to get rid of almost all our fossil fuels, which are the source of the vast majority of cheap, plentiful, reliable energy that our lives depend on, that they are deeply wrong, and that they are putting something over on us, and that the alleged claims of science are not in fact science at all. You have to acknowledge that as a possibility because history is incontrovertible on this issue. So number one thing just to think about, anytime you hear someone try to force something on you or say, oh, science says this, it's obvious. These things are not obvious. So you have the right and the responsibility to think critically about them. And then the second implication of this is what this whole show is about, which is we need a way of critically thinking about scientific claims. Everyone does, scientists for the reason I said, and non-scientists. And at CIP we have a method for doing just that. Now I wrote that we have 4 essential questions. In fact, we had 4 before, but we boiled it down to 3 to make it that much easier to remember. And now let me bring on my essential partner here to talk about these questions and help me break them down, and also to talk about the McKibben piece in Catastrophic Global Warming is Dr. Eric Dennis. And he is going to give you a more scientist perspective on the issue, and I'll give you more of the philosopher's perspective. And I think together, I think you're really going to learn a lot. This is an issue of how to think about these issues that we've been talking about for years, and I really think we have some clarifying things. So, Eric, are you there? Welcome to Power Hour.
Thanks. Good to be here.
So, we got 3 questions to ask about any scientific claim. First one, and we're going to go into all of these in depth using McKibben as a case study. The first one is exactly what is being claimed and by whom. So exactly what is being claimed and by whom. Number 2 is what knowledge and ability would they need? Really pay attention to that. What knowledge and ability would they need in order to prove that claim? And do they have it? And a key aspect of this that we'll get into is that the answer is often that people are claiming knowledge and abilities that no one has. There are many issues that we simply do not have the knowledge to to do. I mean, we don't know how to make an intergalactic spaceship. So if someone claims they have a really, really high threshold of proof. Pretty much they have to show you an intergalactic spaceship. If they say they're a scientist of intergalactic spaceships, that doesn't change anything. It's still a problem that human beings don't have the knowledge right now to know the solution to. And so finally, after we know what knowledge and ability they would need, we need to know what are the philosophies and incentives of everyone involved. And this is super, super important and not thought about. We can't just assume that people are just acting automatically to identify the truth and that's it. And we'll see even if they are, even if they're trying to, philosophies and incentives can misshape how they do things. So we need to be aware of that. So let's move on to McKibben. Eric, do you have anything to say about those three questions before we move on?
No, let's go ahead and get into the meat.
All right. So McKibben on catastrophic global warming. Exactly what is being claimed and by whom? And what I want to warn you about at the beginning is vagueness, which is a danger sign. And it means someone is trying to get away with something. If they talk about either who the scientists are, if they're really vague about that, or they're very vague about what is being claimed, that's a sign that they're not being clear, because it's a very different thing for a small group of scientists to advocate something really, to believe something really dramatic, versus a large group of scientists who can agree on something very benign. And McKibben, if you read the article, and I hope you've read it, is very vague about who exactly supports his claims. He always talks about, quote, scientists, as if it's this uniform collection of people who all believe the same thing and who have derived these brilliant conclusions independently. And that is a big warning sign, because that is not how science works at all. And so he says, look, so far we've raised the average temperature of the planet to just under 0.8 degrees Celsius, or just under 0.8 degrees Celsius, and that has caused far more damage than the scientists expected. Now, who are the scientists, or most scientists? There's no clarity in that, and you could make very strong objections that this is very false. If you look at our environmental quality today, just from a common sense perspective, we live in the greatest environment in history. And then again, he says, if you paid attention to the scientists and kept 80% of it underground. So here, the scientists, apparently all scientists, say that we should ban 80% of our most practical forms of energy. So that is very dubious. I mean, because 80% of scientists definitely do not say this. So what's going on here is that they agree on global warming and climate change, quote, scientists do, in the vaguest, most meaningless sense, which can mean a million different things. So Eric, could you talk about like the range of views that come under, quote, global warming?
Sure. I mean, there's the view which basically all scientifically informed people take, which is that over the last 100 years or so, there's been somewhat less than a 1 degree Celsius increase in global average temperature, insofar as you even think that's a meaningful quantity, but let's not get into that. So everyone kind of agrees that we've gotten a little bit warmer over the last 100 years. That's kind of the bargain basement view. There's the view which also I'd say a vast majority of scientists take, that humans have contributed in part to that by carbon dioxide emissions, and that the greenhouse effect by which carbon dioxide traps heat in the atmosphere, that's a finite measurable effect that has contributed to that around 0.8 degree Celsius temperature increase over the last 100 years. There's the view that it's been a major contributor to that temperature increase. And there's also the view that it could potentially increase temperatures by, say, another degree or so into the future. Then there are all kinds of views on a spectrum of how much more extremely it could contribute to warming in the future. So, at the extreme end, there are people, one of whom is McKibben, clearly, who thinks that the greenhouse effect and the various climate processes referred to as feedbacks that piggyback on top of the greenhouse effect, that these things will cause a catastrophic increase in Earth temperatures. And then there are views that it'll cause merely a much more moderate increase in temperature over time. So there's a whole range of views about how much CO2 has contributed to past warming and how much it's likely to contribute to future warming. And there are also a whole range of views about the possible effects of warming at any different level. So even if we assume that there's a couple degrees of Celsius warming over the next 100 years, it's not at all clear that that's a bad thing. There are people who assert that it's a terrible, catastrophic thing. There are people who think it's actually going to be a good thing. So there are differences not only on the amount of warming that's likely to occur, the degree to which CO2 contributes to that warming, and the way that's going to affect our lives. So on multiple issues, there's kind of a spectrum of views, and it's only one little corner of that whole space of views that results in the idea that there's going to be a massive warming, that it's all due to CO2, and that it's going to have a terrible destructive effect on us. That is, a relatively, I think in absolute terms, a narrow and improbable view. Nonetheless, it's held by many people.
Yeah, and we'll discuss when we get to the issue of philosophies and incentives how it can seem as if such a narrow view is in fact a universal view. I just so I wrote some of the bullet points that Eric was mentioning here. I just want to add one thing, which is that there's also a lot of controversy over the use of technology to adapt to any given climate issue. Because if we take a look at the 20th century, for example, the data is pretty clear that, let's say conservatively speaking, climate-related deaths in the U.S. fell by well over 90%, even despite this global warming that everyone is worried about. And what that points to is that a key determinant of the livability of climate is the level of technology. And the level of technology, a key determinant of that, a fundamental determinant of that, is the level of energy. And so fossil fuels are what have given us a much more livable climate so far, and thus many of the forecasts about this factor in human technology and take it seriously. So all of these are being blended into the scientists in global warming, and then they are used to make it seem like all scientists agree with McKibben. Now, McKibben, what he is saying is incredibly, incredibly dramatic and comprehensive, because he's actually really making three incredibly controversial claims that would be really hard to prove. So one is that man-made CO2 emissions are bringing about a dramatic and unprecedented warming. We'll talk mostly about that one. The second is that this is a catastrophe that justifies a near ban on the vast majority of fossil fuels. And the third, the second, let's divide that up. The second is that this is a catastrophe. And then the third is that this catastrophe justifies a near ban on the vast majority of fossil fuels. We'll see with all of these why there's a lot of variation in opinion, and why to say they're not obvious would be an enormous, enormous understatement. All right, so there's this real bait and switch acting as if all scientists agree with this extreme conclusion on McKibben's part. And I think this all points to that it's really clear, really important, I should say, to understand exactly what a claim is so that we can judge the evidence that supports it. And just if you read the beginning of the article, this should become really clear. He talks about if the pictures of those towering wildfires in Colorado haven't convinced you, or the size of your AC bill this summer. Now, just stop on that. Wildfires or the size of an AC bill, as in it being hotter, is supposed to convince you that there's that there's some dramatic amount of global warming coming, that we're not going to be able to adapt to it, and that we need to throttle any and all fossil fuel companies. Like, the idea that you could jump from one to the other is what this vagueness makes possible. And I mean, this kind of fact proves nothing by itself. And then he talks about, well, actually, Eric, can you talk about this claim, the one that these hard numbers that June broke are tied 3,215 high temperature records, and this supposedly proves that it's unprecedented and dramatic?
Right. And there's a lot of this. I hear this all the time about people drumming up these little micro records that are supposedly broken all the time. And it's as if the number of these little micro records that are broken increases to some unprecedented level, then that means we're getting really, really warm. What's really happening is just as people, essentially everyone acknowledges, over the last 100, 150 years, there's been a noticeable, measurable warming of the planet. We're coming out of what people refer to as the Little Ice Age, which had prevailed, maybe was deepest in the 1600s, and we're kind of coming out of that now. And it is the case that over that period, since there's been this natural increase in temperatures, which started way before humans in any substantial way started putting out large quantities of carbon dioxide, we are kind of at the top of that trend over this recent period of history. And so just as a statistical fact, if we're at the top and we're kind of bumping around the top, you're going to have these artificial little records made all the time. But the important thing is that over the last 10 years, there's really been no statistically significant increase in global temperatures. So that's 10 years, that's a whole decade of data, and we've just kind of been bumping up and down, but around the same level. And so all of these little micro records can be made, and that's still consistent with the fact that we haven't really warmed over the last 10 years. So what you need to do is look at a graph of temperature and just see what the warming has been and when it occurred, and the fact that it basically stopped 10 years ago. That's not to say it won't continue, but all of these recent records about what's been going on over the last couple of years or months really are not reflective of any kind of catastrophic or unprecedented warming. They're just kind of a statistical artifact of the last couple hundred years of natural temperature variation.
Yeah, so we're on a an upward slope that's somewhat natural, probably somewhat man-made, and thus, yeah, if we're on an upward slope, then you can expect certain records to be set, especially given there are a million categories of records. It occurs to me, Eric, can you just explain the issue of the greenhouse effect? Because I think a lot of people think that the greenhouse effect implies like a parabolic, or this upward, dramatic upward trend, and it turns out to be exactly the opposite.
Yeah, it is exactly the opposite. What the greenhouse effect is, first of all, physically, I kind of mentioned it before, is just you have carbon dioxide in the atmosphere. There's light coming down to the Earth from the sun. It is reflected off of the surface of the Earth, and normally it would, if there were, say, no atmosphere, it would just go back out into space. But what happens is that the light that is reflected back, and really mostly it's not visible light, it's infrared electromagnetic energy that's important here. So the same kind of energy that you use when you click your remote control on your television. It's just like light. It's just slightly out of the visible range, so we can't see it. That energy reflected back from the Earth's surface into the atmosphere is absorbed by carbon dioxide. And it's absorbed, meaning that the energy basically hits a carbon dioxide molecule and it makes it rattle around. Well, when molecules rattle around, that's what temperature is. When you make them rattle around a little more, because there's a little more energy coming into them, you increase in temperature. So the greenhouse effect is just this kind of natural thing that the carbon dioxide in the Earth's atmosphere, and it's not only carbon dioxide. In fact, by far the biggest greenhouse gas is water vapor. So there are a number of greenhouse gases, one of which is carbon dioxide, and they have this tendency to trap essentially sunlight, but infrared radiation that's reflected off of the surface of the Earth, and keep it in the atmosphere. So the issue is, that's really helpful, but once we have identified that
the causality of it. How is it impacted by increasing concentrations of CO2? Does it start to get warmer faster or warmer slower?
Right, exactly. So this effect is very well understood. It's actually this effect itself, just in isolation, this one effect of how much a CO2 molecule, how much energy it'll absorb, is very well understood. There are precise physical theories that tell us what'll happen. We can make observations that exactly verify those predictions. And what we find is that there's not an exponential increase in temperature as you increase the amount of CO2 in the atmosphere. There's not even a linear increase in temperature as you increase the amount of CO2 in the atmosphere. There's a logarithmic increase in temperature, meaning that the marginal effect of adding a little more CO2 into the atmosphere is increasingly small as we get more CO2 into the atmosphere. So it's kind of the opposite in terms of the greenhouse effect itself. It's the opposite of what they lead you to believe. Now, their theories, their climate models, rely on a whole bunch of other much, much less understood mechanisms that are supposed to exist in the Earth's climate to achieve this radical, supposedly catastrophic increase in temperatures due to a relatively small change in the forcing, the increase in CO2. But the part of it that we know very well, the greenhouse effect itself, the behavior of CO2 molecules, that effect is much smaller than the overall effect that they're claiming.
Right. So if we go to these simple numbers, increasing the number of gigatons, for every new gigaton, it's just making it a little bit warmer and then a little less warmer after that. I mean, it's not making it colder, but it's flattening out so that wouldn't be cause for concern at all. Now, this is not, I want to make clear, we're not here making definitive declarations about how the climate works. We're going to talk in a minute about how corrupt that is for people to do that. What we're just identifying is that this is being put across in an extremely pseudoscientific way because it's treating these facts as self-evidently meaning this catastrophe. It's treating it as everyone agrees with this, as if it's obvious, and it's the farthest thing in the world from that. And if you hear anything Eric says, you will not find one of those things in this article. You won't even find what the greenhouse effect is. And it's meant for a general audience. It's in Rolling Stone. So what this means is the author of this article is being authoritarian. He's saying science says this, that settles it, you obey. And that is not that does not bode well. That is not a scientific approach.
Yeah, and I just want to add one thing. One distinction that needs to be made is we certainly are asserting that there are particular phenomena that we fully understand in the climate, one of which is the greenhouse effect. There are certain types of claims, and it's essential to distinguish these two types of claims. There are certain types of claims which require, in order to validate them, even to begin to accumulate evidence for them, they require a kind of knowledge that we simply don't possess, like claims about the future development of temperatures on the Earth over a 100-year time span with any kind of precision. We have to distinguish those kinds of claims from claims like the absorption profile of a CO2 molecule is X. So we're not here at all denying that there's a lot of powerful science that we've discovered over many years of studying this that tells us a whole bunch about the climate. But one has to understand that merely because we know some things and we know them in detail, and they themselves are somewhat impressive, the fact that we can access the details of the behavior of these infinitesimal little CO2 atoms, that's a great achievement. Nevertheless, there's just a huge chasm between that legitimate scientific knowledge and these claims that they're making, supposedly having near certainty about what global temperatures will be in 100 years.
Yeah, thanks for that clarification. I could see how it could be misinterpreted like, oh, we can't know anything. And that's definitely the opposite of both of our views, which brings us to the issue, which I think is really, Eric has helped me understand a lot. And I think this really will clarify a lot. What knowledge and abilities would he need in order to prove his claim? So let's get into that. All right, Eric, your show.
Okay, well, So on the level of the kind of larger questions, the first one is, before we even get into predicting the future, we need to have adequate records of the past. We need to know what past temperatures were, what past climate was like. Second, we need to, once we have that knowledge and we can kind of use it as a baseline, we need to construct a physical model of what's going on in the climate. So how a whole bunch of different factors that you can kind of divide into the earth, the air, the sea, and the sun, how those things are all interacting and producing all the complicated dynamics which go on and affect global temperature. And then we also need to use that model, given our historical data, to explain things that happened in the past in order to get some confidence that the model is actually will be predictive and is not just kind of a big garbage can of computer code.
Okay, so I mean, for me, I think like the number one thing, I mean, just to put it in my own more layman's terms, I mean, it's can we predict? I mean, if someone says I've got a prediction of the climate, the first thing I think is, do you know how to predict the climate? Can you prove that you know how to predict the climate? What's the level of our ability in these three things, and then the broader issue of climate prediction?
Right. And one thing I should add is that even after explaining, making detailed explanations of past climate behavior, then before you even get an idea of doing something based on this information, you'd want to make relatively unambiguous predictions that you could check. And we can do that. If there's going to be a catastrophe in 100 years and we make a prediction, say 10 years out into the future or 5 years out into the future, which would be much easier than predicting what's going to go on in 100 years, then we can wait 5 years and check it.
Wait, can you just stress that? Because I don't think most people think of that as a point, but why it's easier to do 5 years than 100 years?
Sure, because the climate is a complicated system. It's sometimes people, you might have heard this concept of a chaotic system. It's a term which had some currency. It just means that if you started off in one particular state, it will evolve in a way which could have been totally different had you just started off in a slightly perturbed initial state. So very small differences in the initial configuration of the system, in our case, what's going on physically on the Earth right now, very small differences can make big differences in the end state of the system. And that doesn't mean they have to be big differences in things like the global temperature. It could just mean the little example is a butterfly flaps its wings, and a day later, the whole wind patterns over the world, thousands of miles away from the butterfly have changed because of that one little perturbation. It doesn't mean it's 20 degrees hotter than it would have been, but the detailed nature of the system has changed. So what that means is that when you're physically trying to make predictions about such a system, it's extremely difficult at all because you can never get a precise, detailed trajectory of the state of the system over time. You have to rely on approximations that you hope there are certain regularities in the system that you pick up. But the point is that the more time you allow to go on, the more this chaotic mixing of the climate occurs, and the less you can really be confident that your model is tracking reality over that simulation period.
Well, so, I mean, they would say, I think, something like, we're like the Warren Buffetts of modeling. Now, Buffett invests for the long term, and of course, there are all these short-term fluctuations, but long term, we know that CO2, man-made CO2, drives the climate. So, yeah, maybe we're off this decade, but, we're sure in 50 years it's going to be horrible, even if this 10 years we botched the prediction. And, NASA scientist James Hansen is kind of notorious for botched predictions, and McKibben refers to him as world's leading climate scientist, which I think is true and very revealing. But that's the justification, right? Well, there are all these little things that got in the way, but the real mechanism we're positing is still the fundamental and will still determine the long term, just in the way that, I don't know, Coca-Cola's fundamentals determined its long term.
Right, which is a convenient excuse, but the problem is that these people have been putting out theories ideas about how the climate works since at least the early 90s. I mean, it really predates that, but at least the early 90s, they've had ample time to see. I mean, we've had, 20 years since the start of these predictions. And if they can't get things right over 5 or 10 or 20 years, I mean, there's really no hope. We should have very little confidence that they'd get something right over the scale of 100 years.
So you had mentioned to me this point of, can you account for difficult climate physics issues? Can you just discuss the complexity of the problem that one is dealing with when one says, I want to be able to predict the future of the climate?
Sure. So there are, basic physical questions about how energy flows into and out of the oceans, the water on the Earth, how it flows, into the atmosphere. There are all kinds of questions about carbon dioxide itself, about how much carbon dioxide is taken up by the upper part of the oceans. There are profound questions about the clouds. Clouds are an important part of the climate because they reflect a lot of the light incident from the sun back out to space, so it winds up not heating up the Earth. And the dynamics of clouds, how clouds respond when temperature changes, and it's a very complicated question. There's a whole set of questions about how life, and I'm not talking primarily about human beings, but vegetation, other animal life, affects CO2 in the atmosphere, and therefore, according to these particular theories, how it affects temperature. There's also kind of the hardest question of them all is that we know a bunch of things that even if we can't be very precise, we know a bunch of different effects, how they bear on the climate one way or the other, whether they heat things up or cool things down or tend to dampen corrections or tend to accelerate them. But there are probably a whole set of drivers, climate drivers and feedback mechanisms that we just don't know about, or the magnitude of certain mechanisms we think are insignificant turns out to be not insignificant, and we just don't know about that now. And it's very difficult, given the complexity of the system, to just start writing down a list and believe that you've figured out all the important causal factors.
Is there any kind of analogy you can give to how difficult it is? Because a lot of these things, people they don't think about these cloud feedbacks and energy flows and that kind of thing. Right.
So you kind of mentioned one of my favorites before, which is that if someone tells you he's just designed an intergalactic spaceship that's going to take us to another galaxy out there, at another place in the universe, you kind of laugh at him, because even if he's the best, most brilliant engineer in the world, we simply don't have anywhere near the sophistication that's necessary in order to accomplish that huge feat. And understanding and predicting the climate over any significant period of time is kind of like that. It's easy to formulate the problem. It's easy to put the words together. I'm going to predict what global temperatures are going to be in 100 years. And for someone who doesn't have a real sense of what the complexity of that scientific problem is, it sounds kind of just as plausible as, I'm going to build a new car or something. But it's really something more on the order of, I'm going to build an intergalactic spaceship relative to our kind of present abilities in understanding the climate.
So I just want to step back a second, because the focus today is really what you as a layman can do. And obviously Eric has a level of expertise in this that very few people have. So the reason I wanted to ask him all those questions was just to give you an indication of what it looks like to take a scientific approach to these. But you don't need to be him to be able to ask these critical questions and to have a good, pardon my language, BS detector. I mean, you can ask, like, okay, he's claiming that he knows this definitive thing. How does he know that? Like, how does this seem like something that would be hard? Is that accurate, Eric? Do you think someone can, like just a normal person can ask these kinds of questions and do good critical thinking?
Yeah, sure, because there are a lot of things that a normal person without a lot of technical expertise can observe scientists and engineers doing uh, that are really demonstrably successful. Like, for instance, the space shuttle, theories of physics, for instance, which allowed us to build semiconductor chips that now we can encode the entire spectrum of knowledge that humans have produced over the history of the world. We can encode that into a relatively small little box when it used to take, rooms and rooms full of books. So there are a number of achievements in scientific fields that are relatively easy to judge by a layman, and one can then kind of stack this new field, climatology and global climate prediction in particular. One can stack its successes up against these other fields where we have a lot of well-verified successes, and fields where there was no success at all, like medieval alchemy or the phlogiston theory of heat. So there are a number of different kind of comparisons a layman can make simply based on the bottom line results that the field demonstrates that don't require technical expertise. It doesn't require technical expertise to know we've been to the moon and to know what an incredible achievement that is. And so one should ask, if you're making these incredibly impactful recommendations for changing the entire nature of our economy, what are the great impressive predictions you've made or successes you've had which should be understandable to a layman? And it's not the case that it's some kind of metaphysical necessity that anytime you have profound knowledge, you can prove it to a layman. But for a field that's making such bold claims and wants so much control, it's perfectly reasonable for a layman to ask, show me your track record, show me what you've done in terms that I can understand.
Yeah, and it seems like, so prediction, I think, has a big element in terms of what you can demand of someone who has a given scientific theory, because of course it's a theory of cause and effect ultimately. So if there's a given set of causes and they understand, then they should be able to predict the effects. But there is, and I want to jump down a little bit and then I'll go back to some of these other points, the issue of modeling, which I know you have a lot of familiarity with. It's amazing how we're basically told it's kind of the same as with science. Look, the computer said this. How can you argue with computers? And so we have this quote down here where he says, the 565 gigaton figure was derived from one of the most sophisticated, notice sophisticated, not accurate, computer simulation models that have been built by climate scientists around the world over the past few decades. And the number is being further confirmed by the latest climate simulation models currently being finalized in advance of the next report by the Intergovernmental Panel on Climate Change. So as someone who actually makes a living doing mathematical modeling and presumably does it successfully sometimes and unsuccessfully others, what is this? How convincing is this?
Well, it sounds very impressive. I mean, there are sophisticated models. There's an intergovernmental panel. But when you really get down to the nitty gritty, again, when you bite off a problem that is orders of magnitude more difficult than what you can chew, it doesn't matter that you're in the top 0.001% of the world expert climate modelers. It's just too difficult to begin with. So it doesn't impress me much.
So what is the status in terms of knowledge of all? It's got all these lines of computer code in it and all these numbers. So how do you regard those?
Well, let me start off by saying this. Anytime, and this is a project which has millions of lines of computer code associated with it, and tons of detailed components within this model that each of them has the possibility of either corresponding to reality or not corresponding to reality. Anytime you have an undertaking like this, a massive attempt to understand an extremely complicated system, there's a kind of process which tends to lead to success, or at least leads to you understanding whether you've achieved success or not. And there's a different kind of process which just leaves you out in the sky, out in the clouds, so to say, without any idea as to whether you're approaching reality or not. And the one process that leads to success is where you take each component and you test it individually. And when you build a car, you make sure the carburetor works, and you make sure the alternator works, and you make sure the tires work. You don't just kind of close your eyes and take any parts, irrespective of whether they look good, and throw them all together and hope your car works. So when you're building a model, you need to kind of test each of these components and think of all the possible ways you could test all of these things in combination and individually, kind of in a bootstrapping process that allows you to go from, hard work and failure and then ultimately success on a subcomponent, and kind of build on that, as opposed to just throwing everything together and rolling the dice on it. That, if you just, go into your parents' basement and write 1 million lines of computer code, that's an attempt to simulate some complicated system without real demonstrable tests of detailed successful predictions. If you kind of just, hope it works and throw a bunch of stuff together, it's guaranteed that it's going to be a failure. And the strategy in climate modeling, they justify it because the problem is so difficult. They simply don't demand a detailed level of predictivity on the same level of, say, a model of physics, or an engineering specification for a building. Or even kind of like a financial disclosure or something that has kind of a detailed plan of how it's going to adhere to reality. There is really no detailed plan for how these climate models will adhere to reality. There's just kind of the hope that they'll throw all this stuff together, it'll look plausible, and then the end result will be something that they like.
All right. So with all of this in mind, I want to go back to just remember the beginning of this. So we have global warming is terrifying new math, 3 simple numbers that add up to global catastrophe. I mean, with all that we're talking about here, it's just so corrupt to treat the issue as simple. So he says 2 degrees Celsius, 2 degrees Celsius, that's obviously going to lead to catastrophe. Well, no, he has no means at all. I mean, he's a journalist. He has certainly no means, but even the unnamed, mostly, quote, scientists that he's referring to say that they know that 2 degrees Celsius is a catastrophe point, that's just made up. The fact that the UN said it, we'll get to that in a couple minutes, does not make it more credible, to say the least. And then 565 gigatons causes 2 degrees. Again, it's garbage in, garbage out with these models. 2,795 gigatons. We don't know that it'll cause 2 degrees Celsius warming with the greenhouse effect. I don't think it would alone. 6 degrees, again, it's just someone made a model who had a complete incapability of doing so. And I want to address the issue, Eric, if you talked about, even if it's the 0.1% of climate scientists, my feeling is that if you're really in the 0.1% of climate scientists and you're honest, you will not participate in making public predictions that are impossible to do objectively, because it's really irresponsible, and especially if it's leading to very, very dramatic changes in our way of life and dramatic cuts to the foundation of our prosperity. I'm curious what you think about that.
Yeah, well, there's no doubt it's not the top 0.01% climate science. I mean, it's kind of silly to talk about the category of climate scientists. We should really be talking about the category of scientists, because the so-called climate science or climatology has been so politicized that it's not a representative selection of scientists in general who are in climate science. But there's no doubt that there's an adverse selection process by which the people who fall into climate science do not tend to be the ones who are the best scientists. I mean, I've observed it myself. In physics departments. Their physics departments are, to a certain extent, feeders into these climate modeling projects. And it's certainly by no means the top physics students who are going into this stuff.
Yeah, we'll talk a little bit more about that in the section on incentives. So let's go, and we'll get through these much more quickly. I really wanted to go through the sort of more scientific one in depth, because that I think is the most confusing to people. But it's also important to go through the other two claims. So given that it's arbitrary to say that there's this incredible, unprecedented warming, but let's stipulate for a second that it was true, because I want to point out that his second and third claims are completely baseless, and this is in a field I know much better, which is economics and energy. He says it necessarily be a catastrophe. And yet, as I referred to earlier, all the evidence we have about human beings and climate is that it's energy and industrialization that's the number one determinant. I mean, when people are free, I was talking to a colleague of mine today who's a geographer, and he was just saying, look, if it was just the temperature that went up, I mean, over time, people would move just as they have in, previous generations or millennia. It's human beings are amazingly adaptive. And if you don't have this religious view that it's somehow wrong for human beings to impact nature, then if you look at it scientifically, to say that it's obvious, that it's like simple, that it would be a catastrophe to have a lot of warming, that's not true. There's been a lot warmer temperatures in the past. You would need to show a lot. You would need to know a lot about economics to make this kind of claim. And McKibben doesn't even acknowledge it, except in this really unfair, really disturbing statement about the CEO of ExxonMobil, Rex Tillerson. And this is particularly meaningful to me. I don't know Tillerson at all, but this is, ExxonMobil is the descendant of John D. Rockefeller, who's, in my view, one of the greatest heroes in American history for bringing petroleum and therefore light to millions and millions of people and extending their days by hours and hours. And now, of course, they're powering the global transportation system, the global agricultural system, and there's nothing comparable to oil in terms of its value, in terms of portable fuel. And he just, callously said, but what Tillerson said was he made the point that human beings could adapt. And McKibben was so offended by this that it led him to say there's not a more reckless man on the planet than Tillerson. Well, there's at least one, and his name is Bill McKibben. So, he is nowhere near the knowledge to make this, and he all the evidence is he has the opposite of knowledge. He's radically ignorant, and he doesn't even acknowledge the complexity. And then finally, the third one is, if there was dramatic, unprecedented warming, again, we'll stipulate that, it would necessitate a near ban on fossil fuels. Now, to know that, you would have to know both the magnitude of the warming, the inability of man to cope with it technologically and through freedom and capitalism, and you'd have to factor in the value of fossil fuels. And yet, guess how many times he talks about the value to human life of the source of 85% of our energy, and the source that has more than doubled the human life expectancy over the last 200 years. The source, McKibben, I believe, is McKibben is born in 1960, makes him about 52 years old. Statistically, he would certainly, he wouldn't make it out of, any of us. We wouldn't make it to age 5 statistically. 52 would be a very, very lucky man. He is alive because of fossil fuels. I'm considerably younger. I probably, statistically, I wouldn't be alive with fossil fuels. And yet, on not one occasion does he ascribe any benefit whatsoever. So he's treating something as simple, and yet he can't even conceive of doing like the most simple kind of cost-benefit analysis. So all he does is just assume that they're just pure evil and condemn them. And the one thing, and I don't have time to go into everything that's wrong with this, but the one piece of economic evidence he gives, and let's leave aside whether this concrete is true, he cites one day, literally one sunny Saturday in late May that Germany generated nearly half of its powers from solar panels within its borders. That's a small miracle, and it demonstrates that we have the technology to solve our problems. So just like a wildfire in Colorado demonstrates that we have catastrophic global warming, then we have to shut down energy production as we know it. So one day of solar producing half the energy, not even the whole day, because obviously the sun is not on all day. So some fraction of a day, there's some jolt that amounts to 50% somewhere on the German grid. That proves that we can replace all transportation, all electricity in the world on McKibben's extremely ambitious is the wrong word, but extremely devastating time scale, with solar, which along with wind power has this terminal defect so far of its intermittent, so it doesn't come reliably. So the fact that you can get a jolt of it illustrates exactly the problem with it. As a German colleague of ours, Stefan Henn, was emailing me about, he has to live with the German network, including all the extra cost it's added to electricity. And he was saying this proves exactly the opposite. It proves that this is not exactly what you don't want. This kind of these unreliable spikes. So, but that he takes this, and this is his example of why that's his only concern about economics. So again, he's making this claim of human catastrophe and the necessity of a certain policy, both of which involve which require an intimate knowledge of human adaptability, human thought, economics, and he demonstrates himself to be radically ignorant of them. Not only radically ignorant, he doesn't acknowledge the need. For him, it's all simple, and all of this points to there's some kind of bias going on. So before we go on, Eric, do you have anything to say about those points?
Well, just one thing. It's kind of funny because this whole movement is predicated on a supposed solution to one of the most difficult conceivable scientific problems, which is predicting the climate over a 100-year time span. And the one other thing they need to cinch up this ridiculous argument is to predict the progress of human technology over that same time span, which is one of the very few processes which one could argue is even less predictable than the climate for a 100-year time horizon.
But it's more, given freedom, it's more predictable in a positive direction.
It's the direction and the rough magnitude is predictable, but the in any kind of whether we progress by 1,000% or 2,000% over 100 years is extremely difficult to know.
Right. Yeah. And I find both interesting because they don't even acknowledge technological progress. In fact, they think technological progress is the enemy because it requires practical energy and ultimately because it requires transforming the planet. And they view that as destroying the planet, and we view that as improving the planet. All right, so we got maybe 10 more minutes here. So let's or at least we have 10 more minutes with Eric. I might go on a little bit after if we need to. But let's talk about what are the philosophies and incentives of McKibben and the rest of the catastrophic global warming movement. And this is a point that we're not taught to think about enough. And then when I hear people talk about incentives, it's often in a very superficial way, like, oh, they just want power. Oh, they just want money. And that's not convincing to people for good reason, because it's hard to imagine that there's just this whole conspiracy of people who are knowingly do the wrong thing and are just trying to lie to us. And that's why it seems these claims of consensus are so compelling to people. But if we understand how philosophy and incentives work, it becomes crystal clear how this whole racket works. But we know so far with McKibben, he is trying to get away with something. He is not being honest. He's claiming things are simple. He's claiming things are scientific, and he's ignoring basically every scientific consideration you would need to take into account to have an intelligible viewpoint on this issue. And I want to just recall remember, it's very common for advocates of government coercion to invoke scientific certainty or near certainty to justify destructive unscientific policies. So now we're going to get into looking at, if we ask this question, we're going to get into why why this is the case, because it's a little counterintuitive. How can science go so wrong? And I just want to make the point that this is a lot easier to do if you watch the patterns of when this happens when you're dealing with unanswerable questions. So I have this example here. If someone claimed the speed of light is 200 million meters per second, if they claim that, that would be no, you couldn't put that over on the public, because scientists would rebel against it. You can prove that it's about 300 million meters per second. It's refutable in that way. But what if you're dealing with something that you can't really know, and often that involves sort of predictive sciences or pseudosciences? Then it becomes difficult, because you can have it incentivizes like a certain group of people who want to make a name for themselves, or they have an agenda or whatever. They can go out and make a bunch of predictions. If they have any PhD, they can claim to be scientists. And then if they're making up arbitrary stuff, then it's incumbent upon others to say, well, look, you're making up arbitrary stuff, but they have to go out of their way, and they can't point to it's not like they have an alternative theory themselves, because the point is there is no theory to be had, or there's no kind of remotely certain theory to be had. So it's a very big incentive for one side and a disincentive for others. And so, I mean, the way I have it here is, who's going to go out of their way to break down the sophistry? Some do, but it's a few. And of course, they're called deniers. And then how much grant money will be available for saying something is invalid? Like, is the government going to give a grant if you say, well, there's not the claims that global warming is catastrophic or arbitrary? If there's any kind of establishment in place, the answer is definitely going to be no. And even kind of on an interesting level, to say something is not happening, or is effectively saying nothing is happening, which isn't really much to get a grant for.
And it should be noted that it's not just will the government give the money to these particular researchers asserting imminent catastrophe. The question is whether the particular funding agencies within the government, whose budgets are predicated on hyping this potential threat up, whether those funding agencies will continue the money stream to these researchers.
Yeah, and that gets into this issue of establishment that I want to talk about. So, quick note on philosophy, which is here on the outline. It's very important. I mean, one of the ideas, Center for Industrial Progress is a very philosophical organization. We basically think the philosophy of environmentalism, or as if we often think it's more accurately called anti-industrialism, needs to be replaced by a philosophy of industrial progress. And philosophy really pertains to two key issues. What are the fundamentals of thinking? Like, what are the fundamental principles and policies you should follow in thinking? And what are the fundamental principles and policies you should follow in action to do what's right? And those two ideas sort of converge in another central aspect, which is your view of human nature. And with our belief is that you need to use reason with extreme precision, and what we're accusing McKibben of here is using it, in an extremely destructive way, or not really using reason, or using a distorted version of reason. And that's why it's important to be philosophical, to be able to catch all these fallacies and to be able to do the right thing. But ethically, you have to know where is someone coming from, because McKibben is often called world's leading environmentalist. An environmentalist is fundamentally someone who believes that human beings must be subservient to the rest of nature. Go read his work if you don't. I mean, not this article, because he's not focused on that here, but if you read his other work, it's all over the place. It really puts nature in a very similar position, or they might call it the ecosystem, to a god in religion. And that means that, if you notice, he spells planet with a capital P and nature with a capital N. So he himself, he's a religious person, and these things are definitely connected. And, one of the basic beliefs is that transforming the planet is immoral and ultimately self-destructive. And at Center for Industrial Progress, our view is transforming the planet is essential to human life, and done under a proper system means a system of property rights that protects everyone's rights is improving the planet. So you have to know, when you hear us, you have to know our philosophy too that's relevant to evaluating our claims. It is one of our claims in a certain sense, although we'll make it explicit, and McKibben will often hide his when his philosophy is inconvenient. So this is the explanation why he completely devalues energy and he's obsessed with these alleged negative impacts, because his pre-existing philosophy tells him that human beings are the scourge of the earth, at least insofar as they industrialize and transform the earth, and that transformation is evil and self-destructive. So why should he pay attention to the energy that, multiplied crop yields that keep 7 billion people alive? He's focused on the alleged destruction of the future of the planet with a capital P, even if he's referring to models that have no predictive value. And so this gets to the final thing of, once you're going to always have people with different philosophies, different ideologies. But one important point about this is that when the government is involved, and the government is incredibly involved in science, and I'll hand this over to Eric in a second, it creates a real monopoly, and it really stops a diversity of views and a free exchange of views. Eric, can you talk a little bit about the government establishment in science, since you've been around it, and how incentives work?
Sure. So, the fact is that all of the money, and there's a lot of it that's going into climate science research, is coming from government funding agencies. And as I was alluding before, the agencies, one, they have a long history of funding this stuff, at least since the early 90s. And two, their future funding is predicated on the idea that this problem is really serious. And if the problem were proven not to be serious, it would be extremely embarrassing for all of the funding agencies, and not just the scientists themselves, but the kind of high echelon bureaucrats who are streaming billions and billions of dollars into these programs. So and not only that, but it's not like there's 1,000 different agencies out there. It's a much more centralized process where there are a handful of prominent agencies with a lot of money, with a small number of actual decision makers who are responding to kind of the intellectual milieu, the what's in the air about what's the new trendy topic. And they're not only responding to that in a long-term sense, they're setting that. But the important thing here is that it's not a set of disinterested truth seekers who are attempting to funnel money to what they are convinced by the balance of the evidence is the most promising area of research. It's an institutional structure in which people's careers are based on the catastrophic nature of this supposed problem, the supposedly catastrophic nature of it.
All right. That's really helpful. I want to just run through a couple of these points the way that I formulate them. So we've got this idea: government is a central funder of science, and that necessarily creates a kind of establishment where it's deciding what ideas are good, what ideas don't belong. And this is usually consistent with the mainstream philosophy of the leaders in the cultures, and it becomes very self-reinforcing. So it decides what views or ideas are worth pursuing, and it makes or breaks careers accordingly. And by the way, this is wrong no matter what the ideas are. So once you've got this establishment, everyone has incentives to work within it. And also a point we've discussed, but it bears repeating, science is super specialized. So a given person, it's not like there are a million people who know all the details of climatology or even understand the basic problems. It's a lot of, quote, scientists or technicians in these tiny little micro fields. And so they're not even in a position to evaluate these big problems. So they just kind of absorb and they do their job. And, when they're asked to sign a very vague statement, like these societies make, which are the problem we discussed before, they equate global warming with catastrophic global warming and bans on carbon emissions. They sign the statement. I mean, they trust the establishment, but they're not making these independent judgments. And then Eric and I both know people personally to whom this applies. Anyone who tends against the establishment is going to be disincentivized. I mean, if you're suspicious of the whole field in the first place, if you think it's mostly government created, there's a lot of government created corruption, why make yourself miserable? Richard Lindzen, leading climate scientist, came on my show and said that you should not go into the field because he couldn't make people suffer. What does that say? I mean, this guy is a leading guy at MIT. So in undergraduate school and graduate school, you're going to get ridicule. It's so hard to find a job in academia. It's so hard to get accepted into journals. It's everything is stacked against you. And there's this whole establishment view. So the problems you then are attacking are, how bad is global warming? Is it this bad? In what way it's bad? And your whole incentive is to find a new way that's bad. You're basically the field of climatology, as Pat Michaels said on the show, is something like finding problems that are caused by global warming. That's become its mandate instead of understanding the climate, because that's where all the money is. That's what they view as their purpose. And then another key point is that the scientists themselves, it's not like they're getting together on a collective megaphone and announcing their conclusions. If they did, that would be way too much complexity for someone like McKibben. It's media people and governments that are trying to manufacture these artificial consensuses, and they themselves have, their own views. So journalists like McKibben, he is taking his cues from the establishment. He's ripe to believe capitalism causes catastrophes. Those are the scientists he's going to call. That's just the way it works. And if you go to the UN, there's anti-capitalists around the world. They have every incentive, every desire to kind of throttle the most successful companies and believe that capitalism is destructive. And you can look into this more. It's worth looking into. But the whole process is completely, it is from top to bottom. It's shaped by this government establishment where certain philosophies combine with certain incentives to manufacture the appearance of this, quote, scientific view that is exactly the opposite of science. Eric, do you have a couple more minutes or do you have to go?
I should be out of here soon.
All right. Well, I think the rest of it I can handle. So do you have any closing comments?
Well, just one additional aspect in terms of the kind of the processes that go on, especially in the scientific bodies, the societies. There's also there are all kinds of levels of adverse selection here. So there's adverse selection of the people who want to go into this field. There's adverse selection of the people who go into the kind of the funding racket in the government. And there's adverse selection of people who rise to the top in these political organizations, which bill themselves as scientific societies. So it's frequently the case that there are agitators within the scientific societies whose main goal is to achieve a certain political outcome and who are themselves not even reasonable representatives of that scientific field.
All right. Do you want to depart with any final words just to listeners or viewers, hopefully, about just how to approach these scientific claims?
Well, one is not to just resign yourself to never understanding anything. As I said before, you've got to take a step back and you've got to do two things. One is to gauge the larger society that's producing the institutions that are funding and making possible this research, and as we're talking about before, what the incentives of those institutions are, and to kind of realize that societies with different ideological directions tend to produce scientific claims that are conducive to that ideology, whether that ideology is good or bad. And the second point I wanted to make is about the ability that you have to simply compare the results of a given program of research to those of other programs of research that have demonstrably bettered human life. And so you can compare climatology to various kinds of technology, to various other sciences, and you can ask, what have they really delivered that that doesn't demand taking them on faith as a layman that they're actually producing results. And when you do that, you'll find very little evidence in favor of the proposition of catastrophic global warming.
All right, Eric, thanks so much for joining us on the program, and we'll speak soon.
Okay, thanks.
All right, so thanks again to Eric Dennis for being on the show. So when we look at this whole system of incentives, what we have got is the result is that, I wrote it down here because I wanted to just sort of remember it precisely. A journalist religiously attached to an anti-capitalist, and I'd add anti-industrial, anti-transformation of nature philosophy, uses some bogus math, vague appeals to science, out-of-context weather events, and citations of virtually worthless computer models to claim that it's simple, that capitalism and fossil fuels are terrifyingly bad, and confidently calls for the destruction of industrial civilization's foundation, as well as condemning the energy producers who work day in and day out to produce that foundation. And this, again, is the power of philosophy. It can be profoundly influential. Someone's philosophy, their method of thinking, their view of ethics, their view of human nature can be profoundly influential for good or evil. In terms of thinking, we have to be really careful, use concepts precisely, not in this vague, interchangeable way where we're package dealing, making these packaging global warming and catastrophic global warming. We need to use math precisely, not just throw out numbers to intimidate people who don't know better. We need to know what we don't know. We need to always keep the full context. And always ask, maybe my favorite question is, what I have concluded consistent with all the facts. And, I'll say when we do our work at CIP, spend a lot of time refuting each other, criticizing each other, finding ways in which our views are wrong, or there's some aspect of them that's wrong that needs to be modified, some articles. And it's really offensive to see someone put out something where the entire methodology is just all completely inconsistent with the facts and defiant of every principle of reasoning I've ever learned. They're just completely dogmatically accepting this philosophy that for man to transform our environment on a large scale is destructive, even though that contradicts all of history, even though, we can, on other occasions or on our website, you can read about how philosophically, economically, scientifically, the exact opposite is true. Transformation improves the planet. And they do this, and then they participate in this establishment. They, either create the incentives or they eagerly lap them up. And the end result, as one of my colleagues put it, is they tell us that food is poison and poison is food. And unfortunately, I don't think enough people have been pointing this out. I don't think there's really been an explanation of how to think about these claims, how anyone can think about these claims, how anyone can realize that this article is horrific, is really unjust. It's unjust to the energy industry. It is terribly threatening to the country to the extent we listen to it whatsoever. And it is profoundly dishonest. And I think you can see here that that this is a viewpoint, that our viewpoint, that these methodological points about how to think about these scientific claims, those can really change the way people think about this catastrophic global warming issue. So Eric and I decided, let's put our money where our mouth is. We will debate Bill McKibben. He can take any climate scientist, any ethicist, any person in the world he wants on stage. Duke University has agreed to host it. We'll pay him $10,000 for someone who scorns money. I hope that's sufficient. And we want to debate him on the topic of the morality of fossil fuels. So we can talk about all the global warming issues, but also all the philosophical and ethical issues, because he has declared the fossil fuel industry to be public enemy number one, planetary enemy number one. I believe that it's demonstrable that they are one of the greatest friends the public has ever had, because energy is the foundation of all that's amazing in your life. So whatever I'm recording this on a Friday, I'm not, it might not come out until Saturday or Sunday or Monday, but whatever you do today, whatever you enjoy, whatever comfort you have, whatever technology you love, whatever food you love, whatever people you love that you can spend time with, remember that they're made possible by energy, and that means they're made possible by fossil fuels, which we produce because they are the best, cheapest, most reliable form of energy devised to date. So for now, and for the past, all other things being equal, we should be profoundly grateful to the people who produce those. And even if it turned out that there was some real catastrophe, the kind of tone of this article is so inappropriate. We would regard it as very sad that this incredible benefit carried with it some incredible cost. And I'm sure that the people in that industry would change their ways. It's just it's so easy to demonize people as, yeah, they just want to kill everyone. That's not true. These people who are just friends of mine who work on oil rigs, these guys do it because it's interesting work, because they believe that they're fueling civilization. And I believe it too. And no one has come close to proving otherwise. And there is unlimited evidence that it is true. So the people who want to shut down the fountain of civilization, that they're doing it because of a bad philosophy, not because of any three simple facts. So, Bill McKibben, bring whomever you want. Alex Epstein, Eric Dennis, Duke University, $10,000. Let's see how our views stack up. It's one thing to write an article in Rolling Stone. It's one thing to do a podcast without you here. I'm willing to put my views and Eric's views against your views, and anyone you can get as the world's most prominent environmentalist, you should be able to get the best of the best. And I believe if you honestly watch what we've had to say today, that you will see that there are fundamental problems with the way you think about these issues. My ideal would be that you refuse the debate because you acknowledge that article was completely unacceptable and fundamentally false. But if you think you're right, you know where to find us. alex@industrialprogress.net. And you, the audience, come on, this debate has to happen. You need to see these views against one another. You need to see the world's leading environmentalists go up against the world's leading organization of industrial progressives. So, first things, how can you promote the challenge? Call McKibben's office. Promote the challenge ever. I've got the links right here. bit.ly McKibben Challenge. Facebook.com/The Pursuit of Energy. That'll just give you updates. Refer people to industrialprogress.net. Here's our Twitter accounts: Alex Epstein, Bill McKibben. Twitter the heck out of Bill McKibben. Keep harassing him. Do not stop. I use harass literally. He deserves to be harassed. He has said something profoundly destructive. He should apologize for it. It has now been formally refuted. We've spent probably an hour and a half doing it. He has a YouTube account. He has the capacity to go on YouTube and watch this. He's been made a more than fair offer at a prestigious university. And one of the debating partners, I won't talk about my own credentials, but is, an extremely brilliant physicist. There's no reason to turn that down, except if you're afraid you're going to lose. Now, if you're afraid you're going to lose, that's understandable, but then recant and then join us in the battle for industrial progress. But, you got to promote this. As I say here, CIP is the first real organization to offer a positive alternative to environmentalism. We have the philosophical horsepower, the scientific horsepower to really change the way people think about these issues. And we're going to start by debating Bill McKibben, and we'll see where the chips fall. So last thing, be creative. Think of anything you can to promote this. This has to happen, okay? The world needs to see this debate. If we can get this debate to happen, then we will have an enduring example of what it means for the environmentalist view and its claim to scientific certainty to go up against the industrial progress view and our view of science. And it'll be right before you, and we'll make it a nice long debate, nice and civilized, and the evidence will be right in front of your eyes. I'm willing to put my reputation on the line. Eric is willing to put his reputation on the line. What is Bill McKibben willing to do? Bill, let's do it. Please accept. For everyone else, again, do whatever you can to promote this. Thanks for joining me. I'm Alex Epstein, and this has been Power Hour.
Power Hour. Life, liberty, and the pursuit of energy. Power Hour. The antidote to shallow thinking about energy issues.